Well, here we are. We've arrived on the very final day of maths for year 2. You've come such a long way since you started all the way back in September last year, and I hope you're really proud of how far you've come. Today, we're just going to finish by looking at some mathematical problems, and we're going to be using everything we've learned this week and everything we've learned over the whole of year 2 to see if we can tackle these fun maths problems. Let's do our final flashback 4 to warm our brains up, and then we'll get going.
Here we go then with our final flashback 4. Have a go, click pause and click play when you're done. Let's go through these answers then. Is 13 odd or even? Well, it ends in a 3, so it's an odd number. It can't be split exactly in half. Question 2, divide 14 by 2. 14 divided by 2 is 7. 3, there are 5 players on a football team. How many players on 4 football teams? Well, if there's 5 on each, 5 times 4 is 20, so there are 20 players altogether. And how much money is there altogether here? Well, we can count in tens and then in ones. 10, 20, 30, 31, 32. So there are 32 pennies or 32p altogether. Okay, let's have a look at what we're doing today. Well, let me start by saying you are awesome. Well done for getting all the way to the final maths lesson of the year. You are an awesome mathematician. So what are we going to be doing today? Well, I have called today Fun Friday Power Maths Problems. And what I thought we could do is have a go at some problems today using everything that we've learned this week and everything that we've learned throughout the whole of year 2, applying all of that brilliant maths that we've learned to these problems. So I'm going to recap today some of the things we've looked at this week, but you can use any strategy you want to answer these problems today. We're just going to do a few quick problems and then we'll finish for the year. So, the strategies we've looked at this week. We have looked at part-whole models. We've looked at how you can partition numbers, break them up into different parts. We've looked at bar models. We looked at how bar models are really good for comparing things and really good for understanding where you are in a problem and being able to represent it. We had a think about using number bonds and how number bonds can make it easier for you to do addition and subtraction calculations in your head. And we talked about using a number line for addition and subtraction and how even though this method might not be the quickest, the most efficient, it's a really good method because it's straightforward, that means it's easy and it's hard to go wrong with. So, remembering all of that and everything you've learned this year, let's have a look at some problems. This is the first question. Tommy has 35p in one hand and 27p in the other hand. Part A, how much does Tommy have altogether? Tommy then buys this box of crayons, and part B, how much money does he have now? So click pause here, think about how you're going to tackle this problem, and click play when you want to go through the answer. Okay, let's talk about the answer. Now, before I start, I want to say in all of these questions today, you might have worked it out a different way to me, and that's absolutely fine. If you worked it out in a way that worked for you, then brilliant. Let's have a look at how I worked this one out. So first of all, we know that Tommy's got 35p and 27p in the other hand, and we need to add them together to work out how much money Tommy has altogether. So I started on 35, I decided I was going to use a number line, and I hopped forward 27. So I went in tens first and did 20 to get me up to 55, and then I added 5 to get me to the next 10, which was 60p, and then I had 2 left to add, which got me to 62p. So well done if you got 62p for the first part. Now we're on 62p. That's how much he's got all together. And he goes and buys this box of crayons for 51p. So I drew a number line again, but this time I was doing a subtraction. So I started on 62p, because that's how much I've got all together, and I hopped back 51. So this was counting back in tens at first, 52, 42, 32, 22, 12, that was 50, and then take one more away gets us to 11p. So Tommy now has 11p. Well done if you got to that answer. Okay, let's have a look at question 2. what is the mass of one of the boxes? So you can see here we've got a weight, 70 kilograms. We've got some 2 kilograms over here that are balancing, and we've also got the boxes on this side. And there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So what is the mass? How much does one of the boxes weigh? Click pause and click play when you've had a go. Okay, let me talk you through how I approached this one. Now, I used a bar model to help me keep track of what I was doing in this question. First of all, I wanted to know how much the boxes weighed all together. I know that whatever is on this side balances whatever is on this side. So on this side over here, I know I've got 70 kilograms, which means over here, I know I've got 70 kilograms altogether too. So here's 70 kilograms, and on this side, it's made up of 2 parts, the boxes and the weights. And I counted in twos to work out how much the weights weighed. 2, 4, 6, 8, 10. So 10 kilograms is what the weights weigh. So I know that to make up 70 kilograms, one of my parts is 10 kilograms. But I need to know what the other part is. That's how much the boxes weigh. Well, I know that 1 add 6 is 7, so 10 add 60 is 70. So I know that the missing number there is 60 kilograms. So that's how much the boxes weigh altogether. But I was asked to find the mass of one of the boxes. So I need to divide 60 up by 10. And 60 divided by 10 is 6. So each box is 6 kilograms. Well done if you got to 6 kilograms. I'll say at this point, if there are any bits that you don't get quite right, that's absolutely fine. Well done for having a go. See if you can go back and work out where you went wrong and then get to the correct answer. Let's have a look at question 3 then. This one is a little bit more tricky. You got to really think about this and use this bar model that's already been drawn for you to help you. Jack has 3 times as many sweets as Dion. Look, you can see that there. There's Dion's and Jack has got 3 times as many. Jack has 46 more sweets than Dion. How many sweets does Dion have? So have a look at this bar model. You can see that Jack has got 3 times as many, and we know that this is 46 more than Dion. Think about how you can use that bar model to help you solve this problem. Click pause and click play when you're done. Okay, let me talk you through how I worked out this question. I think this was a really tough question, so well done for having a go. So the first thing that is a really helpful piece of information is to think about the fact that Jack has got 46 more sweets than Dion. So if we look at this bar model, there's Jack's, there's Dion's, and we know that this bit here is 46 because Jack has got 46 more than Dion. So where Dion's ends, there's 46 to get to how much Jack has got. Now, if we know that this bit is 46, we need to work out then what one of these boxes here is worth. So we need to split 46 in half. Now, you can do this in your head, or you could use a representation to help you break 46 in half. So I drew a part-whole model. I first split 46 into 40 and 6, and then I split each of these in half. So 40 is 20 and 20, and 6 is 3 and 3. So half of 46 is 20. I'm going to add that into my bar model now. So I can see now that those 2 parts were each 23, and together they made up 46. And that must mean that this part here is also 23, because these are all the same size. Well, now I can work out how many sweets Dion has, because look, this part is the same size as this part, because we knew that Jack had 3 times as many as Dion. So this must also be 23. So Dion has 23 sweets. Now that is a really tricky problem, but if you work it through step by step, and if you really understand how the bar model is representing the problem, then you can work that one out. Well done for having a go, and especially well done if you got that one right. Question 4 then. Tommy has a ball of string. He cuts off 4 equal pieces of string. Each piece is 7 centimetres. There is 8 centimetres of string left. What was the total length of the ball of string? Again, have a look at this bar model here. Imagine that this bit on the end is the bit of string left. And these are the 4 equal pieces that Tommy cut off, each of them 7 centimetres. See if you can use that information to help you work out how much string there was altogether. Click pause and click play when you're done. Right, let's talk about this question then. So we need to start filling in this bar model, the different parts. So we know that 8 centimetres was how much string Tommy had left after he chopped off these 4 bits. And how long was each of the bits he chopped off? It was 7 centimetres. So each of these is 7 centimetres. Well, now we just need to add together all of the parts to see how much we have all together. So I did this on a number line, but you could have also done this. You could have done 4 times 7, that would have got you to 28, and then just added the 8, that would have got you to 36. But if you couldn't do that in your head, then I did it just from 0 and hopping along the number line. So I added 7, another 7 to get to 14, another 7 to get to 21, another 7 to get to 28, and then added the final piece, 8 to get to 36. So as soon as you can use the bar model to help you think about the problem, then it just becomes an addition problem and you can work that through step by step. Well done for having a go at that one, and well done if you got it right. Okay, final question of the day. Again, another really, really tricky one. Whitney is thinking of 2 numbers. The sum of the 2 numbers is 78. The smaller number is 31. What is the difference between the 2 numbers? Okay, now, it's really important with this question that you work through each bit really slowly and really carefully. And I'm going to give you some clues at the start. So think about the fact that Whitney is adding 2 numbers together. And when she adds both of those parts, she gets 78. One of the parts is 31, but you don't know what the other part is. So your first step is going to be thinking about, can I work out what the other number or the other part is? I suggest you draw a part whole model to help you think about that. When you've worked out what the other part is, you need to compare the difference between the 2 parts. So think about how you can compare the difference between 2 parts. Have a go at this question, click pause here and click play when you're done. Okay, let's talk this question through. So I drew a part whole model. Whitney was thinking of 2 numbers, here and here. And when she added them together, she got 78. So that's our whole. And we know that one of the numbers, the smaller number, is 31. But we don't know what this missing part is. So to find out this missing part, we needed to do 78, take away the 31, and that would give us the missing part. And if we did that calculation, you could have done it with any method, you would have got to 47. We now know that the 2 numbers Whitney was thinking of were 31 and 47, and together they made 78. The question we were then asked was, what is the difference between the 2 numbers? So what is the difference between 47 and 31? Now, the calculation you need to do here is 47 take away 31. And there's a number of ways you could have done this. You could have counted on from 31 to get up to 47, or you could have done 47 take away 31, and your answer would have been 16. So actually, all this question was asking you to do was do some calculations. But it was tricky to understand exactly what calculations you needed to do. And using a part whole model helped you to think about the question. Now, we are going to finish there. I'm sure your brain is tired from all of that working out. Can I say, whether you got them right or wrong today, well done on giving this a go. It's the last day of term and you've done some really, really tricky problem solving. You should be really proud of yourselves, and it's definitely time to give your brain a break.
Well done, you did it! You have finished all of Year 2 maths. What a wonderful mathematician you are. We hope you really enjoy your summer, have a lovely break, and we'll see you again back for Power Maths when we're back in September. See you in September.